Today we're looking at lesson 59, surface area and volume for prisms. So surface area for a solid is the total area of all the faces and curved surfaces. When you think about surface area, it doesn't have to be just the flat faces. If it's curved, it can still be part of the surface area. Like a sphere, it still has surface area even though it's completely rounded. Does that make sense? The lateral area is the sum of the areas of the lateral faces. Of a prism or pyramid. Another way to say it, it's the surface area excluding the base or bases of the lateral surface of a cylinder or cone. Lateral area or lateral surface area, either one. It is the perimeter times the height. That is for a prism. Is a sphere a prism? So would you use that formula for a sphere? No. Okay. We want to find the lateral surface area of the regular hexagonal prism. To find the lateral surface area for a prism, what two things do we need? Height. Do we have the height? What is it? And what else? Perimeter. Do they give us the perimeter? But can we find the perimeter? How? 10 times what? Minus 6. Hexagon has 6 sides, and it has 6 sides in the picture. Does that make sense? So what is our perimeter? Okay. 60. 6 times 10. And what is our height? So what is our lateral surface area? Does that make sense? Any questions on that? Okay. For a total surface area of a prism, you find the lateral surface area, and then you add 2 bases to that. Do you think you can find the actual surface area of the regular hexagonal prism by yourself? Maybe? Are you having trouble with the base, maybe? Yeah, we haven't done one like this before. You may already know how to do it, you may not. The lateral surface area, what did you get for it, though? What? 2400? Okay. Now we gotta figure out what the base is. So the base is supposed to be a regular hexagon. Obviously, I'm not very good at drawing hexagons or anything with more than 4 sides, but what is the length of this? Okay. So this is the center of it. I made a right triangle. Does that make sense? How many of these pairs of triangle are there? 6 of them. 1, 2, 3, 4, 5, 6, right? So I can do 6 times these triangles. Well, how am I going to figure out the area of that triangle? Do I? The height. Do I know the height yet? Okay, so I need to figure out this height. How many degrees are in this thing right here? 360. How many triangles did I have? So how many would be here? How many degrees? 60. And what would be in each of these two? 30 in each. Does that make sense? Yes. So you just made a 30, 60, 90 triangle. Hexagon's the only one that'll make a 30, 60, 90 triangle. If you have another sided, you're not going to have 6 triangles, you'll have 5. So it'll be 360 divided by 5 or 7. Does that make sense? So if it's a pentagon, you can't use a 30, 60, 90 triangle. Does that make sense? Okay. So what is this length right here? 5. And so how can I figure out my height? Set up a proportion. I draw my little reference triangle. What would go here? What goes here? And then the 2 goes there. Does that make sense? So what proportion would I set up? Do you agree with Chandler? And so what do you get for your height? Yes. Does that make sense? Any questions where the height came from? Okay, so I've got 1/2. What is the base of the triangle? 10. The whole base is 10. And then what is the height? 5 square roots of 3. Do you see how that works? Any questions there? Okay, so the 2 and the 1/2, they cancel out. And then we have 6 times 10 times 5, which is what? 300, yeah. And then we just have the square root of 3 behind it. And it's in centimeters squared. Does that make sense? Do you see how that works? Anything I need to go back over? They're going to give you a lot of these where there'll be a hexagonal base. Anything I need to go over on it? Okay. Looking at volume. It's the number of unit cubes of a given size that will exactly fill the interior of a solid. Have you seen this formula before for volume? Base times height? Area of the base times the height? You think you would be able to find the area of this base this time? Maybe? What did y'all get for your height on this one? 5 square roots of 3. So for the base, how many triangles like this do you have? 6 of them. And then 1/2, what is the base? And then the height. So that's the area of the base, right? And then what is the actual height of the prism? 4. So all of that times 4. Does that make sense? So 6 times 1/2 times 5, and then times 10, 150 times 4 is 600 square roots of 3. And then what would be the units? Does that make sense? Any questions there? Okay. Looking at the last one. Do y'all know what oblique is? It is a prism that has at least one non-rectangular face. And usually they're also slanted. The surface area and the volume of an oblique prism are found using the same formulas that you use with a right prism. But the height is different. If you look at that picture, what number is going to be your height? The height is always from the top, perpendicular. The 40, is that the actual height? No, that's the slant height. Like how far it is from the bottom to the top of the figure, like going from side to side. They'll try and trick you up on those. Do you get the height for the base as 5 square roots of 3? It's the same base every time, basically, so far. So we have 6 triangles. So 1/2 times 10 times 5 square roots of 3. And then times what? 18. So we get 150 from that. And then 150 times 18 square roots of 3. And then centimeters cubed. Does that make sense? Any questions on these? Do I need to go over anything? No? Okay. All right, then your test is tomorrow